Okay, this is question 6 from P4 from January 2022. As we can see, it's a proof question, a proof by contradiction question. Not many of these around at the moment, so we just make the most of them when we get them. Let's just quickly talk about how we solve a proof by contradiction. What we're going to do generally is make an assumption, and then once I've made the assumption, I'll go through a series of logical steps and I'll end up with something that can't happen. And so that means that my assumption is wrong, which means I will be able to prove something. So my assumption tends to be the opposite of what we're trying to prove here. So in this case, what I'm going to do is use proof by contradiction to show that the sequence is not geometric. I'm going to assume it is geometric. Okay, so my assumption is going to be assume, and what have we got here? K, 1 plus 2k, and 3 plus 3k. Assume that is a geometric series. Okay, so at some stage, my logic's not going to work as I go through and try and do that. Well, this is a geometric series question. So a geometric series, what we know is that our functions are a r squared, and so on. They don't have to be ar, they could be any combination of them. Could be ar cubed, ar to the 4, and ar to the 5. They don't have to be the first ones, but what I do know is that this this term divided by that term is going to give me r, and that term divided by that term is going to give me r. Irrespective of whether they were the first 3 terms like that or any 3 terms. So that's what I'm going to use. So even though it's a proofs question which is fairly new, this idea about saying that 3 plus 3k over 1 plus 2k is going to be the same as 1 plus 2k over k comes from the fact that they'd all be equal to the common ratio there. Whether you want to leave that in, I'm not going to bother, or take that out. I think that's fine. Right, I'm really excited about this now then, because I'm going to get a quadratic here, and there's going to be something wrong with my quadratic. So let's just not make any mistakes when we're multiplying this out. Just cross multiply. I'm going to get 3k plus 3k squared here is equal to 1 plus 2k times 1 plus 2k. Depending on how good you are at algebra, I shouldn't really need to do that, but if it means you're not going to make any mistakes, then that's fine. Let's just do it. It works out to be 4k squared plus 4k plus 1. You can take a bit of time over that if you need to. So as I said previously, I wasn't sure what to do at the top end here, but now I've got a quadratic. Let's tidy this up to look like a proper quadratic equation. So take everything over to one side and make it equal to 0. I'm going to get k squared plus k plus 1 equals 0. Well, right at the start up here, when I said I'm going to assume something and then something's going to go wrong, the something that's going to go wrong with a quadratic is that there won't be any solutions. So what I need to do is to check what b squared minus 4ac is. Check the discriminant a bit, and hopefully that's going to work out to be negative, to be less than 0, and then it can't have a solution to the equation. So if you wanted to be really quick, you could just say b squared minus 4ac is less than 0, and just do it straight away. Or if you want to be a little bit slower, you could say b squared minus 4ac works out to be equal to, so that's 1 squared minus 4, which is minus 3, which is less than 0. Therefore, no solutions for k. And so here, I would tend to end in the same thing. I then say, right, my assumption is false. And if my assumption is false, then what I was trying to prove, as in it being a geometric series, was wrong. So I can now say k, 1 plus 2k, 3 plus 3k is not a geometric sequence. And just quickly, as a summary. So, once I've been asked to show that one, I assume the opposite, go through, end up with a problem, which leads to my assumption is false, which leads to going back and saying it's not a sequence, the original thing I was trying to do. So that sort of approach will work no matter what the topic is that we're doing for the proof by contradiction. Okay, hope that makes sense.